Let's dive into the one of the core ideas of computer science, data encapsulation. So this appears all over the place, especially in programming languages. But in a lot of our protocols that we use, such as the way we transmit packets across the internet, there's always this notion of how we kind of like pack data or encapsulate it in certain ways. So with that said, let's see how Java tackles this. Java actually takes this maybe a hair step further than some other languages in that they realize that sometimes encapsulation is part of this enterprise level language, and they've created kind of a feature called a record class that makes this a little bit of a shorthand type notion that the compiler will expand out into a more traditional class. Now I say the compiler expands. That may not necessarily what's happening way down in the depths of things, but it's kind of how we can view it to get a really good idea of what a record class is. So what I would like to maybe do is transition to my notebook really fast just to provide some sort of overview of what it is that I'm talking about. And then after a minute or two, we'll head over to IntelliJ and we'll do some coding to demonstrate record classes. Okay, so a record class. What is not uncommon in Java is for there to be like a large amount of data to be brought in, perhaps, and then data gets kind of parsed out into individual sections to where each individual section is going to look identical to the other one as far as structure goes, but the actual information inside of it will be identical. Maybe the best way to maybe view this would be like I'll try my best to draw the three database disk here. I did a pretty bad job of that. Let's suppose that we have a database and we have a Java program over here. What our Java program may do is it may query this database for like some sort of records. Let's suppose that maybe we're going to query, I don't know, user info. User info. That's what we're going to query from our database. When this database comes back, it's going to be filled with a lot of records. So it's going to be filled with a lot of records. Each one of these records may contain a first name, a last name, a date of birth, who knows what all we may have in here, and then a whole bunch of things where each one of the records are effectively going to have the exact same information. So what we may do is Java, we may actually create what we're going to call a class. Maybe specifically after by the end of this lecture we'll be using what's called a record class. We're going to use a class to basically, for each one of these entries in these records, for each one of these entries in the whole data set that gets returned, each of them being called a record, we're going to input that data into a class. So inside that class, so we're going to have maybe, let's suppose we're going to have a Java class where we're going to hold the first name, the last name, the date of birth. Maybe this will be string, this will be string, and then this will be maybe some broken up integers where the month, the date, and the year are all integers. But we'll essentially store that into a record where in a class where each one of these things is going to have a getter and a setter, perhaps. Okay. Now, if we think about in terms of our database, what's going to happen is the Java program is going to parse these things out. The reason that we use setters, so to be clear, we could actually create a constructor to where we just have the constructor parameters for every. We could have a constructor parameter for every single one of the elements in our for each one of the variables in our class. So that way the constructor sets them all. That's primarily the way that we'd handle it if we're having something automated build up a class. The only reason that we have individual setters is because sometimes that makes it easier for a human to understand. But if we're asking Java itself to be creating its own class or populating the data inside of its own class, typically what will happen is we will create a class where the constructor takes a parameter, first name, last name, month, day, year for the birth date, and whatever else we're going to put in there, and we'll just send it in through the constructor, and then the constructor will initialize all variables, and we don't even have to worry about the setters. That's primarily what will happen, and that's kind of in the thread of what a record class is going to be. So in our record class, our Java program is effectively going to keep creating a bunch of these encapsulated class containers effectively, where this record is going to be stored in this one, this record is going to be stored in this one. By the way, I'm talking about this entire record will be stored in that one, this entire record will be stored in the second one, this entire record will be stored in the third one, and then this will be in here. And we basically are storing the first, last name, date of birth information in these classes, and then we'll have an array of classes that represents the data set. And then that would be a nice way, so that way all we had to do is refer to the class to get the information we want. So we could ask the class, we know that record 0 is for maybe customer 0, and so we asked the class at position 0, give me the first name with getters, give me the last name, get the date of birth month, get the date of birth day, get the birth date year, and then so on and so forth. So that's the idea. Record classes, so we can create our own class, and if humans are going to be using it, maybe we'll use setters and getters, or we can use the record class that essentially is going to make things a lot easier. So I could talk all day about this. Hopefully you get the gist of what we're doing. We're basically creating classes that will primarily only serve the purpose of just storing data, and what we're going to call data encapsulation effectively. So I'm going to hop over to IntelliJ, and let's see some coding examples of it. I'll make all the code that I do available after the fact, after this lecture. So let me finish. Let me just demonstrate the code. I will push that code to a GitHub repository, and then we will basically make that available to you as a URL link. Okay, so here we have essentially a project called record classes, where I'm going to be using this to demonstrate what's happening. We have our main class with a main method. This is going to be kind of our starting point, so to speak, our main driver, so to speak. Now, what I want to do is I want to go over here and I want to create a class. I'm going to go here in this example. Let's just create a regular class, and I'm going to say maybe user info. Let's call it student info. Student info. We're just going to create a regular class with this. All right, we don't want this to help us out anyway, so there we go. Now, the first thing that we would typically do inside of a class for data encapsulation is we would define all the parameters as variables. So we know somebody's going to have a string first name, we're going to have a string last name, and then maybe our date of birth, we're going to say, okay, is going to be integer month, integer day. Let's do this. Integer date of birth month, integer date of birth day, and then integer date of birth year. Okay, so we know that this should probably be between 0 and 12. We know that this one will be 0 between 31, depending on the month, and then we have this one as the date of birth year. Now, we're not going to dive into all these error checking things associated with this. This is basically left at another date. We're just kind of going to demonstrate what a record class is going to look like. So we're not creating a record class right now. We are basically creating a standard class that's going to serve as a way to encapsulate data that we're going to store into it. Okay, now for those of us that we know that there may be a lot of ways that we could have this built up. We may say that we want a constructor. We want a constructor that will accept the following parameters: the string first name, the string last name, and maybe the integer DOB month, integer DOB, whoops, I made a little bit of an error here, sorry about that, DOB day, integer DOB year. Okay, and that's our constructor, or the parameters for it rather. So these are the parameters. If you don't like, this is just to keep it from being horizontal. So typically, maybe if you're used to writing small functions where you have all this kind of horizontally created, that's okay. I basically just list them vertically so that way we could see them. Now, basically what we could say is if we're having Java create these records or this data encapsulation, then probably it would be fine to say Java, just go ahead and populate the constructor so that way the constructor can essentially set these with no problem. So what we would do is we'd say this first name is equal to first name, which is the parameter. This dot last name is going to be equal to the parameter last name that gets passed into the constructor. This dot date of birth month is going to be equal to date of birth month. This dot date of birth day is going to be equal to date of birth day from the parameters. And this dot date of birth year is going to equal to date of birth year. All right, so just to be clear, These are the parameters. So in this particular scenario, we have this class called student info. This class will encapsulate the information of a student, where it's going to provide it's going to store the first name, the last name, the date of birth month, the date of birth day, date of birth year. Now, if we wanted to avoid having setters, what we could do is we could just pass, whenever we construct the class, we would effectively create a constructor that accepts all of these parameters at one time, and then they all get initialized. Okay? Or we could effectively do this. We could say public void, let's do first name. Sorry, let's do set first name, and then we put in here string first name, and then we would effectively do what? Say this dot first name is equal to first name, which is the parameter. So remember, anytime we refer to this, we're talking about the class variable. Without this, we're talking about this, and IntelliJ makes that very handy to see. Then we're going to go down here and we're going to create a getter, maybe a public. By the way, we want to make these private. Remember what we said? We always want to do these things. Sorry, I typed that in the wrong place. We always want to protect these things because we want to have our methods like doing checks on these. So like a month, we would want to make sure that it was greater than what? Greater than or equal to 1, less than or equal to 12. I'm going to leave those checks out for right now, but still, we don't like to have class variables as public unless we have a very good reason to. But anything that may come in from an external source where we cannot make sure that they're okay, we want to make them private. Okay, and these yellow lines just means that, hey, you've declared this, but you're not doing anything with them yet. So now we're going to have a public string, and what I'm going to say maybe is get first name, and then we're just going to return this dot first name. All right, and that's it. And for each one of these things, I'm going to have to create this same set of data. So what I might do is I might just copy this, and then I'm going to come down here. I'm going to paste that, and notice we got some problems. So all I have to do here is just rename this to last name. And then here, I could actually use a kind of a select and then replace, but I'm just going to leave this alone for the time being. Okay, now we got here, we're going to have to get last name and then last name. Okay, so now that we got the set first name, set last name, get last name, I'm going to have to do that for each one of these things as well. So if we see this, that will allow me to have a constructor potentially to where it doesn't do anything other than just allow the class to be initialized, where it doesn't accept any parameters and it doesn't do anything with anything. So remember, after you create one constructor, that's not the default one. If you want a default one, you have to explicitly give it. Okay, so now if we look, we actually probably need to go down through here, and we're going to say public void int, and we're going to say set dob month, and I could put in integer month here. We'll say this dot dob month is equal to month. Okay, after we have, I'm sorry, that was a mishap. So now we hop down here, and now we got the setter, so we're going to have to do the getter. So we're going to say public int get dob month, and I'm going to put integer, put nothing in here, and we're going to return this dot dob month. Okay, so now that we've got all of these things here, we can copy and paste another one to represent the day. So instead of this, we're going to get the day. Sorry, I edited the wrong one. Day, day, and then day. Okay, now we have to edit this one. We're going to do day and day. Okay, so now we go down here and we're going to paste one more to do the year. So it's going to be the date of month, year, 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 and then we're going to put year here. And I'm almost making this painful in a way on purpose, just to let you guys see why there was a need for it at one point. So what we have now is we've effectively got this entire class that I created from start to finish with nothing helping me. This is kind of the way we would do it if we were trying to, create a class that's going to hold it. So we have two different versions. We have two different versions of our constructor, rather. So in one case, our constructor just builds this kind of initializes the class, but doesn't do anything as far as setting values. Then what we could do is the user could effectively use all these setters to set each one of these variables separately. This person would say set first name, set last name, set date of birth month, set date of birth year, set date of birth whatever, day. And then if we needed that data, we'd use all the getters to get them back. Now we have another case. So this is kind of like if a human is actually typing in all the data to make it kind of easier. There would be a little bit of an overhead with that, with like function calling if you like ask for like feedback back from the command line. And then there's other situations where maybe we have the constructor that's going to do it all for us. So if we're like returning records from a database, maybe we'll just have all these parameters at one time that we could pass into another constructor that accepted all these parameters. And guess what? Once we accept all these parameters, then we could just have the constructor set all of them, and we don't have to worry about setting. Then at that point, setting would just do what? Update the values. That's all they would do. They would just update the values. And then we would just use the getters to get the values back. Okay, so to go over here, let's see what this would look like. So we've got essentially, we could have student info. Let's say we're going to create a new student. We're going to say new, or no, we're going to student one, let's do that, equals new student info. Now in this case, what we're going to do is we're going to set these individually. So we're going to say student1 dot set first name. We're going to say that this is Nathan, kind of a really cool name. Student1 dot set last name. We're going to make this Russell. Okay. And then we're going to say student1 dot set date of birth. We'll say that this is, we're just going to call this 3 for March. Then we're going to do student1 dot set date of day. Let's make up 1 to be 20. And then let's say student1 dot set date of birth year. We'll call that 1990. Okay. So at this point, what we have done is we have initialized an instance of student info, and we're calling it student1, right? This is student1, and we're allocating the space and then using the default constructor where we're not actually asking it to initialize anything. Now what we could do is we could essentially say, okay, we're going to say maybe system dot out dot print line, and we're going to say maybe student1 dot get first name. Okay, and when we print this, it effectively does all of that. So it prints the first name. Maybe we could then say concatenate this, add a space, and then plus, I don't know, student1 dot get last name. And then we run that, and we'll see that we get the record for Nathan Russell here in student1. Now what we could do is, you see how kind of maybe tedious that was? This would be very handy if a human is actually writing the code to actually set these individually, or if maybe we were asking for a user to type it into the command line where we would get one entry. It would first say type in the first name, and then it would use the set function for the first name to do it. Then it'd say type in the last name. Then we'd call set last name, take whatever the user typed in, and then put it in there. So that would be where we're maybe trying to get feedback from the human. But if we're writing it from, if we're creating the student class, if we're using the student info class and we're bringing it in from like a database where all the data does not require user input, it's just basically grabbing it and then putting it into the record class. In that case, we may just say, let's just use the constructor. So I'm going to say maybe student 2 equals new student info. But I'm sorry, but instead in this case, we're going to use we're going to use the parameters and then what we're going to do is we have to put all these in here. So whenever I type this in, I'm going to put Nathan, Russell, sorry, let's change the name. Let's call it John Smith. Now, what would the next one be? See, it's kind of helping me out here a little bit. So we've already got the first name. We're on the last name, the date of birth. That's going to be, I don't know, let's suppose this person was born in February. Maybe they were born on the 17th. And then the year is going to be, I don't know, 2002. Okay, it looks like I'm missing a parenthesis. Now, if you look, if I'd had this here, IntelliJ would have helped me out here. So since I'm using the constructor to do it, notice that over here in my student info, that this constructor right here is the one that's being used here. The constructor, this constructor is being used here where I had to pass in all the values, right? And if you see IntelliJ, this is not what I've typed. I didn't type this. This is actually what I typed here. This is IntelliJ just giving me some help. So IntelliJ knows that this constructor requires a first name, last name, date of birth month, date of birth day, date of birth year. And so IntelliJ is basically just making that available so that way I will know and be able to keep track of it. Now, what happens is whenever we were like many years ago, before we had IntelliJ and everybody was using Vim or Emacs or whatever else, and even then sometimes we had some help, it was very hard to keep track. So you'd have people flipping back and forth, or maybe they have a split screen in their Emacs editor, and you'll be, or Vim or whatever it is you use. I always encourage you to always learn those tools because they're very helpful. So you split the screen and you'd be sitting there saying, okay, the first parameter is first name, the second was this. Then you'd like edit, then you say, okay, the next three is going to be month, day, year. Then you go over here and edit it, and then finally you got it. And so now what I'm going to do is I'm going to basically copy this, and I'm going to paste it below. And instead of using student 1, what I'm going to do is I'm going to say student 2 and student 2. And there we go. We see that this one is printing out the information. So in the first instance, I had to use all the setters. I had to use all the setters to set the individual dates because I did not use the constructor. Now, if I'm going to use my constructor, I have to do all of them or nothing because I don't have a constructor for the individual parts. So in this one, I just pass them all in to the constructor and then let the constructor do all the setting for me. And then in that case, all I have to do is use the getters. Now, in this particular case, for student 2, I could use the setters to update a value, but, you know, I don't know. In the course of a program, typically the database would allow somebody to upload it. Usually when Java is interacting with the database, we assume that the data that's coming in from it is going to be fixed, right? Okay, so that is effectively an overview of how we create on our own a student info class or a data encapsulation class. Now, there's one more thing that I want you guys to be aware of. There are some occasions where, such as the example when we're reading from a database, we don't want, if we want Java to update the database, then Java would just basically send that data back to the database and have the database updated, because we don't want to have a lot of temporary things being stored out of the database, because whenever we store things locally and we make changes to be written later, that leaves open a big door for data to be considered dirty, and maybe two different places have opened up the same record set and now they're trying to maybe alter them at the same time, and then whenever one writes it, the other writes over the top of it. So whenever we make an update, you want to get that back to the database as soon as possible, up to certain optimizations. I understand that may be a little bit abusive to say, but that's the idea. So what we may want to make sure when we're creating a data encapsulation class, we may strictly just want the class to hold the data and that we don't actually want the data to be set. In those cases, what we may do is add the keyword final. All right. Oops, I'm sorry. I'm typing here. I'm not paying attention. Okay, so when we do this, we're looking at this, and it says variable first name might not have been initialized. Why did adding this final all of a sudden create that? The problem is because we have allowed a constructor that does this. What happens whenever we label a variable final? It means that once it is set, it cannot be changed after the fact. When we label something final as a keyword in Java final, that means that once the value is set, it cannot be changed. Now, I want you guys to be aware that this has some big implications here. Notice that all of a sudden it appears that this setter has some problems. Let me explain what happens in a class. Whenever you initialize a class, like whenever you either call it by its default constructor, which does nothing, or if you're passing in parameters, a value is always set in a constructor. So for every one of these values that we set, so when these values are set, when these values are declared, they will be set when the constructor is called. When the class is initiated, these things will take on a value. For things that are classes like strings, these become null. First name, last name will be null. For the things that are integers, their initial value will be 0 if they're not set otherwise. So the only thing that can set the class variables is the constructor. So anytime I label these things final, like I'm about to do, you're going to see a whole bunch of issues here where I've labeled these private final, and now it's just complaining all over the place. The reason that it is complaining all over the place is because of this constructor. Notice that this constructor does nothing. If we use the default constructor here, that means that all of these values will be taken on their default value. Once they take on that value, what do we say? Final means that it stays the value. You effectively have something degenerating here to where first name becomes null. Last name becomes null. Date of birth month is 0. Date of birth day becomes 0. Date of birth year becomes 0. And then all of a sudden you're like, well, what does this even do? Well, whenever we have these final things, they have to be declared in the constructor, or we could actually do this. I mean, we could do something like this, I suppose. That is okay, but we're not doing that. We don't know what these values are at compile time, so we're going to have to bring them in. The problem is with this constructor is if it gets called, all of these take on degenerate values, and then it's like, why do you even have them? Okay, notice that when I got rid of that, these are no longer an issue. So why is that? Because now we're only left with this constructor, and to be honest, this is no longer valid because we have to have a constructor that accepts all the parameters at one time. Let's go back. Notice what happens whenever I delete one of these. All of a sudden, we have a little bit of an issue to where maybe some things are not set. Do you see this right here? It says this may not have been initialized, which means, what does this mean? So if I remove this, then we're going to see up here that this is a problem. So you effectively have to set all of these values in the constructor, or else you're going to have an issue. All right, so I need to take all these things back, put them back in there, and we're all set. So we can't have, if we're marking all our values final, we can't have a constructor that does nothing. The constructor is going to have to set each one of these things to a parameter or calculate values or whatever it is that has to happen. The constructor has to assign these values. In this case, I'm creating the parameters inside the constructor so that way they can be passed as the first values that get set here. So if you look, when we go over here, this is the only instance of the class that will work, is where I pass in each one of these values as a parameter to the class while it's being initiated. Then the constructor sets these values. So the question becomes, if they're final and they cannot be updated after they've been initialized, What does it mean about the setters? That is a good point. Notice this. Hovering over it, it says cannot assign a value to final variable first name. What that means is your setters, once you mark these things final, and sometimes you want to mark things final because you don't want to open up the opportunity. You may have a lot of code that's relying on something to be static once it's set. Like reading data from a database, you don't want the class to be updating it. You want the database to hold the good values. So you may say anything that you grab from a read-only database, you want to make sure that nobody can mutate that data. So you mark all the variables that's going to bring into it, mark them final so that way they can't be updated. What that means is effectively all your setters now are effectively useless because you can't change the value of those things once they've been set. And this, anytime you see red inside of IntelliJ, it means that you're probably going to have some compile issues. So you might as well just stay away from it. So you have to fix it. If you see red, you're going to have to fix them. So I'm going to have to get rid of this one because I've declared everything to be final. I'm going to have to get rid of this one too. And then finally, we have nothing but our getters left. So let's see. In my opinion, this is just an opinion. If we hover over this, what's it saying? Found problems with this. Let's see. Where is the problem? Here's the problem. Since we no longer have setters and we don't have the default constructor, this is no longer really reliable. This is no longer reliable. We cannot even use this anymore. So now we're left with a class that encapsulates data that requires the constructor to create initial values, which means since it's going to be a data class, all of the values that are going to be there are effectively going to be passed in as a parameter. And then the class is just going to store that data, and I'm going to use the getters to just get the values. Now, with that said, in my opinion, this is just my opinion. Whenever we have getters, I like for things that are setters to have the prefix set, and for getters, I want them to be get. But I want to show you a trick here that is possible. If you wanted to, you could just say, since we're no longer having to distinguish between getters and setters, and we know that we're only going to have getters, you might just want to do this. First name. Okay? And then last name. So what does that mean? That effectively means that the getter is effectively just the variable name, only pitched as the name of a method, which means this is the getter. So the getter so we have a variable first name in the class, that's final. That means there are no setters, so everything's going to be a getter as far as that variable. What we could do is we could just name the getter the variable name, and there'll be no resolution problems as far as like resolving whether it's a variable or a method, because the methods will have this kind of open close parentheses, and there'll be no issue. So why don't we do that? Let's just label all of these things that are variable name, and let's just do that. So we have date of birth month, then we have date of birth day, and then we have date of birth year. All right, so now that's easy. So now we go over here to this. We realize this is no longer cool, so we're going to have to rename this. Get first name, and then get last name. All right, so all of the parameters, since we've marked everything final, which means that the constructor is going to have to set them, we had to create a constructor that had all the parameters passed into the constructor. And then the constructor sets all of the class variables, these, using the parameters that are passed into it. At that point, all we need now is, since the setters are no longer reasonable because we can't use them to change the final variable, we don't have to distinguish between the setters and the getters. We just name the getters effectively the variable name, and anytime we want to have a getter, we just put the two open close parentheses behind it, and we get it. So here we're passing in all the data for John Smith, and then when I want to get his first name, I just use the method first name, open close parentheses, last name, open close parentheses. All right, let's see if it works. I hit the run button, and sure enough, look, everything is working just fine. So now the question comes back into play is, if you think about this, whenever we're creating a data encapsulation class where the variables are final, where everything is passed in through the constructor as a parameter, where the constructor essentially sets each one of the class names from the parameter, and you see that all the getters are just the variable names. If you notice, all we really have to do is, if I had like an intern working for me or something like that, I would say, you know what? Here's the name of the variables and their types. Does that make sense? I could say, hey, I'm going to give you our record class or our encapsulation class needs to have a string first name, a string last name, an integer date of birth month, an integer date of birth day, and an integer date of birth year. That would be all I would have to hand to the new intern that knows absolutely nothing, and I'd say, go create a data encapsulation class using that knowledge. Well, if the person knows the variable names and the type, then they would know how to create this. They would effectively use the type and the variable name and just use private file in front of it. And then for each one of those, you would have a constructor parameter where it was the type and the variable name for each one of them. See how all of those are effectively the same. All of these are effectively the same. It's just you change a little bit of it just to make it fit. And then down here inside the constructor, it's going to basically do everything where you have the variable name, this dot variable name equals variable name. Then we have down here public string, whatever the type is, give the variable name, then open close parentheses, return this dot variable name. Notice how all of this works just fine with no issue whatsoever. And that the only information that I would have to hand an intern is effectively the type and the variable name, and they'd be able to expand all this out. Well, the Java developers realize that since Java is an enterprise level language and it's going to be handling a lot of records to and from places, not that other languages don't, it's just that the Java people realized how simple this was. And what did they decide to do? They decide that they're going to add a feature where we're going to be able to create what we're going to call a Java class, but a very specific one called a record. Now, this is what I'm going to call student info record, just to give it a different name, because all these things are classes. They're just declared differently. So remember how I had student name as the kind of the, what do you say? The class name, student info. I'm going to create another one, but I'm going to call this one a record because we're going to make it a record. Now, when I click this, here's the way it looks. It looks almost the same, except there's a little bit of difference. We say public record and then student info record. See how the name should match the record name? Okay. So we still have this IntelliJ does for us. So effectively, here's what I'm going to do. All I have to do is define the constructor, and Java will build everything else out. So in here, I'm going to put string first name, string last name, integer date of birth month, integer date of birth day, integer date of birth year. And then guess what, guys? That's all that you need to do to create a record. This public record right here is all I need to do to create something that is equivalent to this. So if you look here, I've got 44 lines of code for so all I'm getting out of this person is a first name, a last name, a date of birth day, a date of birth year. That's all that I have. And then we have to make sure we have a constructor. And then we have to make sure the constructor sets all of them. And then we have to create getters for all of them. So here where we have 44 lines of code, this student info record effectively creates the exact same thing. Now we can add other things, and we will later, but this is effectively all that's needed for Java to basically expand out and create this equivalent class. And to give you an example, let's do it. Let's suppose now that I'm going to say, let's hop down here. We're going to say student info record, and we're going to say cool student. We'll give that name, and then we're going to say equals new student info record, except here I'm going to pass in the, since this is going to be a cool person, let's go ahead and put Nathan. Why not make this person cool, right? We're going to put Russ. You see how IntelliJ's helping me? That's not always present. That wasn't always present in years past, so it's kind of a nice thing now. Then we're going to say the birthday, what was it? March. And then the birthday day was going to be the 20th, I think. And then we're going to have 1990 or whatever. Okay, now let's see if we can copy this and see if it behaves the same way. So student, let's say, what was it? Cool student. Over here, same thing. And then we hit play. And we see that that has happened. So what does a record class do? A record class effectively allows you to create a class that's specifically meant just to hold private final data, to where it will automatically create a constructor for you, and the constructor will set the values accordingly, and then it will create a getter. So if you define this, then it's going to make that one of the getters. So effectively, we're going to have a first name parentheses as a getter, last name parentheses as a getter, date of birth month as a getter, date of birth day parentheses as a getter, date of birth year parentheses as a getter. So that's effectively it. I mean, that's pretty cool. I think that was kind of a nice, neat feature. It basically just takes something that is so amazingly expanded out, but so predictable, into something to where if it's going to be used a lot, then we maybe should just have something that's easy. And what the compiler will do is it will expand all that. It will create the constructor for you. It will create the getters for you. It will make everything handle exactly like these two things are. Student info and student info record are effectively the same thing. Now, pay attention to this. Public class student info, that's how you declare a regular class. Notice that here we're not declining as a class. We're saying public record because a record is a class. There's no need to be redundant. This is effectively it. Or it will expand out to a class. You can treat it just like a class. So we have public record. Now, does that mean that you can't add certain things to it? So maybe I go over here and you know what? I want to have this toString information. So what I'm going to do now is I'm going to say public string, and I'm going to say toString, because remember, that's what actually gets printed when you ask to print a class object. And what I'm going to do is I'm going to say string is equal to, I'm going to say student information, and then I'm going to say, okay, that's good. Whoops. I'm going to say string info. Okay. Now we hop down here and we're going to say plus equals, and we're going to do tab, and we're going to say first name, and then we're going to plus this, and we're going to do first name. Okay. And then it's going to be plus equals. Forgot that. All the way down here, we don't even have to have, we could probably just have these plus signs down through here. And then plus last name. We just keep concatenating all this. Date of birth, we're going to get a little bit of a pass on here because we can combine everything down into one. We could say date of birth month, date of birth day, and then date of birth year. Okay, and then what we're going to do is we're going to return info. And so when we go over here and we say, okay, we want to, instead of having all this information, how about we just say we print the student's record out by just calling the toString method. Remember what this toString method is? This toString method gets automatically called whenever we, the toString method gets automatically called when we call a class using a print function. So anytime we make a reference to a class using a print function, it's going to print out that toString method. So we're going to say student, what was the name? Student 2. And then we hit play and we see, oh, little mishap here. So we're going to have to do forgot the new lines here. Sorry about that. All right. So when we do the toString, whenever we try to print the object toString, what does it automatically call? It automatically calls the toString method. Okay, well let's suppose since this student info record class gets kind of built for us, we don't have the opportunity to do that, right? No, actually it turns out that it is perfectly fine to just copy this toString method as one of these extra things that we need. And so if we remember, when we declared this, it made a class variable available called first name, and it made all the getters, so we could use this identically as we did before. We just pasted it in there, and so now we have the ability to do the exact same thing with a record class, to where we could actually add extra variables. We could actually add, we can't add setters for those variables because once they're set, they're final. By the way, I want to make sure it's clear. In a student info record, whenever a variable is variables are always defined to be private final, which means you can't create your own setters. You can only basically maybe create other variables that get set or whatever else you need, but you're effectively stuck with whatever the constructor sets these as. But you can add others if you want to. Well, not really. We probably don't want to add variables. We're just saying we could add other methods that do operations on these variables, whatever. Just keep in mind these record classes are just basically meant for holding storage. So I would be careful about venturing too far out. I would always create a toString method so that when somebody says just print this record, you'll know how to do it. Maybe sometimes you might want to have like where you get it passed, or you may want to convert it to a JSON object or something like that, or maybe you might say to JSON or something like that where it creates something like that. Sure, but that's effectively it. So we go back here, do system.out.println, and now we're going to call that cool student object, and then we hit play, and notice that it effectively does the same thing, except for this is going to be for Nathan Russell instead of John Smith. That is effectively what a record does. It essentially allows you to have a very shorthand way of creating something that is traditionally always created in the exact same way. You create from this with just like maybe a handful of lines of code, it expands it out to being equivalently this. So we've condensed 53 lines of code down into 18, and there's also one more benefit. If we hand our intern this kind of information and say, hey, create this student info class for me, the problem is that the student info, there's always a chance that a human could make a mistake. Maybe down deep in here they accidentally say first name should equal last name, and then all of a sudden your code's misbehaving and you're not really quite sure. You assume that maybe the intern couldn't possibly have screwed up something so simple, but we don't want to be mean because we've all made those kind of mistakes. So the less that you write, the more or less prone they are for errors, right? So if we have a record, if we're trying to store records, then probably our go-to method is a record, and then we'll just add maybe the toString or the toJSON type stuff if we want to add like the enhancements for displaying it or handling it some way. That's the idea. Now on our next lecture video, when we cover it, we'll be covering string builder subclasses, which are very, very useful, and I will show you guys how those work in another lecture. But effectively, the idea for those is that whenever you have gigantic constructors full of parameters, that is terrible for somebody to write code to sequentially enter them in there, right? So let's look over here at main. Whenever I was calling this, do you agree that I had to actually type in each one of these things for that? Now, the idea, that could be a little cumbersome. So maybe we want to have a record class, but we still want to have user input from the outside world. A string builder class, when we cover it, will allow us to enter these individually and then call a method called build, which will then build the record class for us. Alright, so hopefully this is not a big deal. Hopefully you see the power of this. Hopefully this made sense. Hopefully you see just how important this was. So what I'll do now is I'm going to push all these changes that I've made, and I'm going to say git add, git commit, lecture demo changes, and then we push that up. And so now what I'll do is I'll make that link available to you so you can go in here and play with these things, take a look at them directly, or just look at it from the GitHub repository, whatever. So I appreciate your attention. I hope that you enjoyed this lecture, and I hope it was informative to some extent. Thank you.